5.3, we're going to do polynomial factoring. Okay, you do not need to know 5.1 or 5.2 to do this. We will go back over those lessons, but today I just wanted to start with something that everybody could do regardless of what you remember, okay? So polynomial factoring. If you remember our flow chart from earlier in the year, we have GCF, pairs and patterns, and trinomials. That is, all we're going to do is more of that, okay? But we're going to add some patterns today. So the first thing we're going to do is we're going to add to that flow chart, right? So we have pairs/patterns, okay? And we're going to up the degree, right? It's polynomial, so we're going higher than degree 2. So we're going to start with a difference of cubes. So that's a cubed minus b cubed. Okay, and we're going to look at how it factors. Now, it's a formula, okay? So the first thing I need to be aware of is that these are perfect cubes, okay? So we're just going to think, what's the cube root? A, right? The cube root of something cubed is the base. And the cube root of something cubed is b. And a and b are going to be the starting points of this formula. So in order to factor this, the first factor is going to be a minus b. And I say minus because this is a subtraction, so the sign is going to stay the same. Now it's cubes. So this is going to be a bigger factor. It's actually going to have 3 pieces. Okay, so how do we get this factor? All right, I like to tap my paper while I'm doing this. Okay, so I have a. I tapped it twice. A squared. Right, so a times a. A times b. B times b. Notice that you have each letter 3 times. A times A times B times B. All right, so now you're like, well, what about these pluses and minuses? Okay, so let's look at our signs. Now, if you multiply the last, negative b times b squared has to be b cubed. But it has to be negative b cubed. So this last term has to be a negative times a positive. And so this one is going to be a positive b squared. Now, when I am multiplying all of this out, if I were to continue to FOIL and distribute, I would need these things to cancel out so that I am left with a cubed and b cubed. And so this sign here is going to be opposite. So I have an acronym for you. It's called SOPS. Oops, SOPS. Yeah. Yes. Sorry, no, just SOPS. SOPS. Okay, what does that stand for? It stands for square. Opposite product. Opposite product and square. Okay, right? Because you got to memorize it, guys. There's no way around this. You have to know this formula. Okay, so we're taking time to build the formula and looking at ways to remember it. So here we go. A cubed and b cubed. Ding, ding, ding. They're perfect cubes. I'm going to start with the a and the b. and it's going to be the same sign. Okay, so you've got to get this first factor. Step 2, fill in the big one. Okay, A times A squared, opposite product. Okay, opposite the negative, A times B, square it, B times B. All right, A times A, opposite product, B times B. That's your formula. Okay, so now I'm going to write down A cubed plus B cubed. So I changed the sign. Now this is not perfect squares, okay? So the sum of cubes actually does factor, okay? Here we go. First thing I need to do is the cube root, which means I need to find the numbers, the A and the B. And then I set it up, right? I got one small factor and one big factor. Right. The first factor has the same sign. So it's A plus B. Okay. Square, opposite product, square. Right. A squared. Opposite product. See that minus? Opposite squared. And just check that sign. Look at that. Positive B times positive B squared is positive B cubed. If you were to do all of this multiplication, all those middle terms would cancel out and you would get just this. Okay, so this is your formula. There isn't another way to factor the cubes. You have to know the formula for it. Okay? Trying to just figure it out is not gonna work. All right, so let's do an example. Okay, so as I get ready to do my example, I'm just going to make a little chart over here with some number, the perfect square, and the perfect cube. You don't have to draw the shapes. And I'm just going to write down 4, 11, 12, okay. And I'm going to write down what the perfect squares are, and then I'm going to write down what the perfect cubes are, just so that I can start trying to recognize what numbers are perfect cubes. Because the perfect squares have been like drilled into our mind since like elementary school or middle school. Okay, I'm going to get a little scratch paper here just in case. How do I find a perfect cube? Well, you do the number times the square, and that gives you the perfect cube, right? Because then you multiply it 3 times. So 2 times 2 times 2 is 2 times 4, which is 8. Okay, 3 times 3 times 3, which is 3 times 9, which is 27. So it's the number times the square. That's how you get the perfect cube. I'm only doing this once so I can try to start recognizing them. Okay, so 16 times 4, 24, 40, oh, it's 64. 36 times 6. Okay, more scratch paper. Once you start recognizing the cubes, you don't have to multiply this out, but if you're not sure, start with the perfect square and then multiply to see if it's the perfect cube. So 49 times 7. Okay, so I'll give you a minute to fill out the rest of these numbers here. Multiply them if you need to. Ooh. Come on back, multiplication. You can do it. It's feeling a little rusty. Hopefully, check my arithmetic, make sure I didn't mess it up. Okay. All right, let me know if you disagree with anything I wrote. All right. Okay. Are we good? 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 Got some nods? Got some nods? Olaf, you have it written down almost? Almost? Yes? No. We're just writing it once. Just so that you can come back and reference it. Right? Because if you don't have a calculator and you're like, oh, I don't remember my perfect cube, you're just going to have to multiply it to check. All right? And once you do it a few times, especially these smaller ones, they're pretty quick to multiply. And the cubes aren't going to be that big. Okay? All right, here we go. Our first example. X cubed minus 64. All right, my first thing. Are they perfect cubes, right? I can't use the formula unless it's a perfect cube. 64. All right, notice 64 actually shows up as a perfect square as well, but x cubed is a perfect cube. That means I want to use my cube formula. Okay, so I can write the cube root of x cubed is x. The cube root of 64 is 4, because I have to find my numbers before I start the pattern. Okay, here's my pattern. Make the first factor match. X minus 4.
Why is it minus?
Because we started with a minus. Good question.
Oh.
Right, this first sign always matches what was in the problem. Okay, then we got a big factor. Here we go. Right? Tap, tap. Square. Opposite product. So I'm going to plus it for the opposite sign. And I'm going to multiply the x and the 4 together. Square. 4 times 4 is 16. See that? What's 4 times 16? This is always the perfect square number. 4 times 16, 64. Okay, this is it. And you're like, well, how do I know that I'm done? Okay, now this chart that we have, it's a loop. You just go through it until you can't factor anymore. So I made it here to the green. I just did the cube factoring. Oh, I still have a trinomial. I still have a trinomial. Is there any way that we can factor this? Can you multiply to 16 and add to 4? No. That means that you're done. That's it. Whoop. Problem solved. Yes. No, I'm not looking at the negative. I'm looking at the number. The negative is this minus is taken care of right here. Okay, so I'm just looking at the numbers, not actually the subtraction. Okay, let's pick out, okay, here we go. I want to try 27x cubed plus, okay, let's pick a number off of our cube list. I like 1. No, I like it. I like 1. It's a good one. Kind of funky looking. Okay, here we go. I have to figure out, okay, I see x cubed, so I'm like, gee, maybe these are perfect cubes, so I'm going to check. The cube root of 27x cubed is 3x, the number and the variable. Now, the cube root of 1 is just 1. Ones are just 1. Okay, I've got my two numbers. Let's write the pattern. One little, one big. Okay. 3x plus 1. That's the first factor. It's a plus because the problem started with a plus. All right. Square, which is 3x times 3x. So it's 9x squared. Opposite product. So this is 3x times 1 square, which is 1 times 1. Look at that. 1, 2, 3. 1, 2, 3. Plus. Because if I check my signs, it has to be a positive times a positive. Okay, it's a formula. You have to know the formula. Okay, we're going to do one that's a little bit tricky, and then we'll do a little whiteboard practice, which actually we might do the whiteboards post-lunch. Yeah. Okay, so it's 3x plus 1. It's a good question because when we start with a plus, the first factor uses the same sign. When I started with a minus, the first factor started with that. Yes?
What do you mean by like the tabs?
Oh, okay. So, because I like to, I don't know, do something when I'm trying to remember the formulas. So, 3x times 3x. 3 times 1. 1 times 1. It just helps me, like, 3x times 3x, 9x squared. 3x times 1, 3x. 1 times 1.
But we don't have to do it.
Oh, no. Just remember the formula. You got SOPs. You can write it out 3 times. You can tap your paper. However you feel like getting that formula down. All right, here we go. Question 3. Okay, we're going to get crazy here. Perfect cube we haven't used. Ooh, 8x to the 9th. Yeah, the 9th. You can do it. Okay, plus or minus? Plus, okay? Another perfect, 125. Okay. Cube root of this is, okay, well the cube root of 8 is 2. You're like, is he x to the 9th? That's weird. Okay, what do you multiply 3 times? X cubed multiplies 3 times to get x to the 9th. That means that the cube root is 3, right? Cube is multiplied 3 times. Okay, the cube root of 125 is 5. So my first factor is this. Everything else is built off of the first piece. Okay. Right, there's my tabs. 2x cubed times 2x cubed is 4x to the 6th. I will see you after lunch. Okay, so we got the cube roots. Now notice with the higher exponents that I checked x cubed times x cubed times x cubed is x to the 9th, all right? So that's how I knew that x cubed was the cube root. Once you get the first factor, the second factor comes into place. So 2x cubed times 2x cubed is 4x to the 6th, okay? Notice that if you were to multiply these two things together, you would actually get 8x to the 9th, okay? Multiply, so that would be 2x cubed times 5. That's the middle term. And then the last term is 5 times 5. So x times x, or sorry, a times a times b times b. Okay, now comes the whiteboards, right? Find your whiteboard and your marker. We're going to put up a couple problems here just to see if we can do that formula. All right, here we go. Okay, here we go. You got a whiteboard? Whiteboard. Okay, grouping is something, right? See that chart? It's right underneath trinomials, okay? We're going to do problems that have to be done with grouping today. So grouping can only be used when there is an even number of terms. Okay, that's when you can use grouping. And in order to do grouping, you split the polynomial into equal groups. So depending upon how many terms you have, you can split it any way you want as long as the groups have the same number of terms. Okay. Now, a little hint for grouping is we're looking for common ratio of coefficients. And that's just something to help us to try to pick out what groupings might work best, is you're looking for some common ratio with the coefficients.
Wait, can you stop one?
Mm-hmm. Okay, so I'll let you catch up, and that's going to be our first example. Okay, so with grouping, all right, I have 4 terms. Okay, so I have an even number of terms. I have to split the polynomial into equal groups. So the only way to split 4 into equal groups is 2 and 2. So I'm just going to draw. It's the same kind of grouping that we did back with factoring, except I already have 4 terms. All right, so here we go. What's the GCF in the first grouping? X squared. Right? So the GCF comes out in front, and we're left with 3x minus 2. Okay, so then I look at the second grouping, minus 3x plus 2, and there's no letter, and there's no number really, so it's a 1. And in this case, it's a negative 1, because you don't want to have a leading negative there. All right. If done correctly, you'll see the common factor, right? 3x minus 2. And so I'm going to pull the 3x minus 2 out front as the GCF, and I'm left with x squared minus 1. All right, that was iteration number 1 through my loop. Iteration number 2. Go back up to the beginning. Do I have a GCF? No. Do I have any pairs or patterns? Not here, but here. So this particular piece right here is a difference of squares. That means I'm not done. I have to rewrite that one. So the purple is going to turn into x minus 1, x plus 1. And so my answer is all 3 of these. So how do I know that I'm finished factoring? Because each of these things is linear, right? The powers are all 1. There's nothing left to do. Okay, here we go. Let's try this one. This one you do x cubed minus 6x squared minus 25x plus 150. Okay, there are 4 terms. Means there's only one way to make the grouping. Okay, try it. All right. Who can tell me what the GCF is in the first grouping? Yeah. X squared. Fantastic. What goes in the parentheses? Somebody else? Isa?
X minus 6.
All right. Fantastic. All right. Second grouping. What's the common factor? Harrison? Negative 25. Okay. Somebody else? What goes in the parentheses? Jane?
X minus 6.
All right, magically, we've done it correctly because I ended up with the same x minus 6. All right, so I'm going to take my x minus 6 in front, and then I get, but I'm not finished because I go through my second iteration on my factoring choices, and the x squared minus 25 turns into x minus 5, x plus 5. Notice 1, 2, 3. It's cubic. It's cubic. Okay, so we had a really good question earlier. What if you have 6 terms? Right, 4 terms is pretty straightforward. You're like, draw my line in the middle. Okay, 6 terms can divide evenly in groups of 2 or groups of 3. And so our last 2 examples are going to be with 6 terms, and then I'll turn you loose to finish anything in your homework, okay? I'm going to flip my page because, yeah. Wait, we good? Okay. Number 3. Okay, here we go. X to the 5th. Notice this degree just keeps going up. Minus 3x to the 4th. Plus 2x cubed. Minus x squared. Plus 3x minus 2. Okay, now I'm actually going to write that problem twice because I want to show you what the 2 possible groupings could be. So I'm just going to leave one line here, and I'm going to write it again. Okay, and you're like, what does common ratios mean in terms of grouping?
What do you find is easier?
For how to group it? Whichever one works. So I'm going to show you how to predict which one's going to work. So you don't have to do all the work and then end up wrong. Okay, so here we go. The first line, I'm going to split them into groups of 2. Right? The first one, I'm going to split it into groups of 2. Right? Equal groups. I just have 3 groups. And I'm going to look at the coefficients. Look at the coefficients. 1 and 3, 2 and 1, 3 and 2. You're like, that doesn't really mean anything to me. Okay. Groups of 2, 1 to 3, and 2 to 1. If we're talking ratios, how do you get from 1 to 2? You multiply by 2. How do you get from 3 to 1? You divide by 3. It's not the same. You've got to have the same ratio. So next, I'm going to split it into 2 even groups like this. And then I'm going to look at those coefficients. 1, 3, 2, 1. Oh, see that? It's the same coefficients. Now, I didn't look at the pluses or minuses. I was just looking at the number because I'm going to have to work this out to make sure that it works, okay? But when I say ratio of coefficients, I mean look at the numbers. 1, 3, 2, 1, 3, 2. Those are the same numbers. That means that your grouping should work. Okay, so not the first one. We're going to do the 2 even groups. So you do your GCF minus 3x okay, then I see a common -1 here. Okay, look at that, guys. You've got the same factor here. That's how you know that you've done your grouping correctly, is you have the same factor that shows up. Okay, there's my grouping iteration. Back up to the top. I have a trinomial, so I'm just going to look at the trinomial first. Can I multiply to 2 and add to -3? Yes, I can. That means you factor it. Right? I have 2 more factors. I've got to do at least 2 more loops, 1 for each factor. Okay, so this one turns into x minus 1, x minus 2. And this one, ooh, I got to go back up. Iteration number 3. Perfect cubes. I've got SOPs. Okay, so this one here turned into those two factors. Okay. This one here is the SOPs, so those are the things I'm looking at. Right, I got my formula down. X minus 1 square, opposite product, square. Okay, and this piece turned into this. Yay! All right, that's your final answer. How do I know? Because linear, 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 quadratic. Can you multiply to 1 and add to 1? No. That's why I don't do anything with that, because it doesn't work. Yes. Mm-hmm. Okay, last one. I know it's a lot. You can do it. You're doing so well. All right. Yes, I'm just looking at them. Okay, 1x to the 4th, negative 16x squared, minus 5x cubed. I know it's not in order, but just go with me. Plus 80x, minus 6x squared, plus 96. Now, I really do prefer all of my like terms and stuff to be combined, but I will tell you grouping works no matter what if you can get the common ratios and everything works out. Okay? So, let's do groups of 2 and check the common ratios. All right. And I'm just going to check the common ratios to see if I have a chance of making this work. 1 and 16, 5 and 80, and 6 and 96. Okay. 1 to 5 and 16 to 80 times 5. 1 to 6, 16 to 96. Times 5 times, I think it's going to work. Okay, so let's try it. The GCF. Now, I'm not checking my pluses or minuses, so you just have to be careful with them. I'm just looking at the numbers to hopefully give me the right direction. Minus 5x, okay. All right. If you don't know what it divides to, then you're going to have to do your division. Okay. Okay, so there we go. Checking my division. Hey, look at that. However you group it, as long as you end up with the same factor, it doesn't matter. It doesn't matter what order it started in. You're just looking for the same factor to happen after you do that initial GCF. Okay, so we go x squared minus 16. All right. Oh, iteration number 2. Okay, right, so we've got 2 quadratic factors. You've got to check both of them, right? So you just loop back through your factoring choices. Difference of squares. Loop back through regular trinomial. Okay, multiply to negative 6. All right, there it is. Voila. You're finished.